Hello everyone. In this video we will see about an operational amplifier. So here we will perform a non-inverting amplifier, inverting amplifier and voltage follower using an op-amp. Basically an operational amplifier is a multi-terminal device which internally is quite complex. Fortunately for the ordinary user, it is not necessary to know about the op-amp internal makeup. So here you can see a basic symbol of an op-amp, and here we can see an IC pin diagram for an op-amp. So here it have an basic three terminals. Two are the inputs and one is the output. So here this is called an inverting terminal and this is called non-inverting terminal. Suppose if we ground the positive terminal and then if we give the input signal to the negative terminal, the output will be inverted output. And then if you ground the negative terminal and then if you give the input to the positive terminal, then output will be non-inverting output. So here we can see an op-amp basic pin diagram. So here this is called an inverting input, 2 is, and 3 is called non-inverting input, and 6 is used for output. So 7 and 4 is used for to given power supply V plus and V minus. Here we have an offset null. So if the output gets shifted from the basic level or normal ground level, so it will be get restored by using an offset null. So the basic characteristics of an op-amp is always it should have an high input impedance, it should have an output impedance is very much low, and bandwidth is very much high, and then the gain is very much high. So what are the reasons for this? So if the input impedance is very much high means, then whatever the source we are having in the input source, that will not be get affected. And then output impedance, so we should get the proper output in the output side. So if we have a high resistance over in the output side, then we will not get the proper output. So the output impedance should be very much low. And then gain, so the gain is nothing but output voltage by input voltage. So here the op-amp should produce a maximum gain, because if we give a small input, that should be get amplified and then we should get the maximum output. So always the ideal characteristic is the gain should be very much high. So for high frequencies also the gain should be very much high, that's why bandwidth is very much high. So these are the basic ideal characteristics of the op-amp. So now we will see an basic Ltspice. In Ltspice we will perform an inverting, non-inverting and voltage follower. So here I have used an OP07 device. The device is called an OP07. So this is the device I have used over here, which is called precision operation amplifier. So now here I have given supply, which is supply as an plus 15 and minus 15. So here we can see positive and negative and positive. So for positive 15 is given to the plus and negative is given to the negative VCC. And then we are going to perform inverting amplifier. So I'm going to give the input on the negative terminal and positive is grounded over here. So here I need to form a closed loop. So I have given the negative feedback from the output side. I have given the negative feedback. So R1 resistance 1.5k and R2 resistance 13.5k to perform a proper output. So here I have given a sine waveform with a frequency of 1 kHz with a maximum amplitude of 1. So now let me simulate this one for inverting. This is the input and this is the output. So let me zoom this. So you can see here the input is black one and the output is blue one. So here we can see the input is very much small and the output is very much amplified, and then we can see the output gets inverted. So this is called inverting amplifier. The next one is we will see for non-inverting amplifier. So in the non-inverting amplifier we should not invert the input. So for that what we have done is we have made a negative terminal to the ground and we are giving input to the positive terminal and with the same configuration. Let us see how it works for non-inverting. So let us give the input and let us get the output. So now let me zoom it. So here we can see the output is not inverted, but the output gets amplified properly over here, where the black is input and blue is the output. And next one is called a voltage follower. In the voltage follower, whatever is the input, that should be given in the output. It is more or like a buffer. So there we don't need to V naught is equal to Vi. So that time we don't need to use any resistance over there. So if you go for derivation part, we will come to know about the inverting amplifier, non-inverting amplifier equations. Whereas here in the simulation part, I didn't explain all those things. Just I am saying that V naught is equal to Vi. So here, whatever is the input, that will be get followed in the output side. So here we can see, so we have given an input and then we have got the output. We can see it here. So here we can see it here, both are same. Whatever is the black one, that has been same output, both are followed properly. So this is how we can perform and any operations by using an op amp. Thank you for watching.